Hey mathematicians, so today's video is going to discuss scientific notation. So just a note, scientific notation is just a way to write large or small numbers as the product or multiplication of a number between 1 and 10 raised to something. So if 10 is raised to a positive number, it's going to move the decimal to the right. If it's raised to the left, negative, it's going to move it to the left. So when we write in scientific notation, what we have is a large number. We want to make it a small number between 1 and 10. So that means the decimal is going to go behind the first digit, which means you got to find out how many places you moved it. So if it goes behind the 2, that means we have 2.34 times 10 raised to something. So just check and see how many decimal places you moved it. So 1, 2, 3, 4, 5, 6. So 2,340,000 is just written as 2.34 times 10 to the 6th. It's a much tighter, neater number. Here, we have a very small number. Could be the number of inches wide your hair is, I don't know. It's 0.0000234. So again, put the decimal behind the first digit, so 2.34 times 10 to something, and find out how many places you moved it. So 1, 2, 3, 4, 5. And it's a negative 5 because we moved it to the right, which means when you undo it, you're going to move it back to the left. Now to reverse it, to write 0.0000234, you just take the 2.34 times 10 to the negative 5th and move it 5 places to the left. 10 to the 6th, move the decimal 6 places to the right. So what we're going to do is use exponent rules to multiply these things together. So two very big numbers, 2 times 10 to the 3rd and 4 times 10 to the 5th. So use the commutative property to put the 2 and the 4 together. Then we put the 10 to the 3rd and 10 to the 5th together. Then we remember that we multiply powers, we add the exponents. So 2 times 4 is 8. 3 plus 5 is also 8. So 8 times 10 raised to the 8th. Here we have 1.2 times 10 to the negative 4th. That's an incredibly small number. Times 3 times 10 to the 6th. So a very large number. So we're going to reorganize these again. 1.2 times 3. We're doing this because these are like terms. Right? They don't have an exponent. Times 10 to the negative 4 plus 6, because that's the rule. So 1.2 times 3 is 3.6. Negative 4 plus 6 is 2. So 3.6 times 10 to the 2nd. Whenever you do this, always check to make sure your answer is in scientific notation. Is the decimal behind your first digit? Yes, so we can move on. So one more example. 5 times 10 to the 6th is a very large number, times 3.5 times 10 to the 3rd. So 5 times 3.5 times 10 to the 6th plus 3. So 5 times 3.5 is 17.5. 6 plus 3 is 9. So 10 to the 9th. You gotta pause, because again, 17.5 is not between 1 and 10. So the problem here is that we need to move this decimal one space further. So we want to make it 1.75. And if we add 10 to the 9th, move it one more place, we know we added 1 to it, so we got to make it 10 to the 10th. Last but not least, we have dividing. Remember, the rule for dividing is we're going to subtract the powers. So the rule for the coefficients is the same. So we have 6 divided by 2 times 10 to the 4 minus 2. So 6 divided by 2 is 3. And 4 minus 2 is 2. So 3 times 10 to the second is where you're going to get. And check to make sure, is this in scientific notation? Yes, it is. The decimal, even though we didn't write it down, is right behind the 3. 4.2 times 10 to the negative 4th. We're going to look at that in a second. 3 times 10 to the 4th. So we're going to subtract these powers. So 4.2 divided by 3 times 10 to the negative 4 minus 4. So 4.2 divided by 3 is 1.4. Negative 4 minus 4 is negative 8. So if you look at this, it's going to be a very small number, but it is still in scientific notation. 1.4 times 10 to the negative 8 is 0.0000000014. So something very, very small.